Hello, my name is Steven and I'm going to be making their stat video. Let's start off by defining some words. Lower class limit. You're going to be given a list of something called classes, and it's the smallest number. It's the smallest number in each class. I will define class in a very short while. But lower class limits, the smallest number in each class. You'll be giving a number of classes and you find the smallest one. The upper class limit, actually it's the smallest numbers. It's the largest numbers in each class. Well, I guess the way I'm writing it should be singular. It's the largest number in each class. The class boundaries. That's probably the hardest one to understand. It is the midpoint of all gaps. The midpoint of all gaps. There will be gaps in the numbers. We find the number in between them. Like if I'm thinking 1 to 2, and then, 1 to 2, and then there's a gap, and then it goes from 3 to 4. 2 to 3 is the gap, and we want the midpoint, the number right in the middle, which is 2.5. The definitions will be a little bit abstract now, but once we start using them, they'll be straightforward, and you should definitely write these down. That way you have them in front of you. Class boundary, to find it, you find a midpoint. But this is different. I'm asking for the class midpoint. In a given class, the number in the middle. The value in the middle of each class. Okay, keep talking about class. What is a class? We'll get there. The class width. The class width is the difference, that means subtract, the difference between any two consecutive lower class limits or the upper class limits. Just subtract any two that are next to one another, consecutive. Now, going to use these definitions to answer some questions. Suppose you are given the following numbers. And I'll put it in increasing order to make life a little bit easier. But these numbers do not have to be from smallest to largest or largest to smallest. They don't have to be that way. If they were not, well then we should put them that way. Again, if in your textbook you have it where they're not in order, the first thing to do First order of business is to put them in order. 40, 43, 44, 43 again I have. 44, 44, 44, 45. So this is the numbers. In the top row we have 4, 5, 6, 7, 8. Looks like 9. We have 8 numbers. In the second row we have 5, 6, 7, 8, 9, 10. In the third row we have 4, 6. We have 9 numbers. And in the last row we have 4 numbers. And when I add these up, I get 31. Okay. Now, you want to find the class width. And the class width, this is very important. The class width is defined this way. Round up whatever ends up in here. Round up whatever ends up in there. Okay, now we want to make a frequency table and cumulative frequency table with 6 classes. So we're going to, the rule is you take the highest number on the list, subtract the smallest number on the list, and I'm telling you to make 6 classes. So you divide by 6. Okay, I guess we didn't need to know the total. And you do the arithmetic. So you round it up. This is 47 over 6. Well, what's the first number that's over 46? That's over 47. The 6 goes into 48. 48 divided by 6 is 8. The class width is 8. The first class is going to start with 13. Now, I also defined, when you're given a table, I defined the class width. So I'm going to put a class here, and then underneath I'm going to put another class, and then another class. In fact, I'm going to put 6 of them, because we're going to have 6 classes. That information was given. Now the class width we defined as you can subtract the lower endpoints. The exact terminology, the lower class limit, which is 13. You're supposed to get 8. Class width is 8. That is, these two numbers differ by 8. These two numbers, they differ by 8. They differ by 8. Okay, so I'm kind of running out of room, so it's 13, 21, 29, 38, 46, and 54. That's the lower class limit. That's the lowest number in the first class, 13. And 21 is the lowest number in the second class. Well, what are the upper numbers? Well, here you're going to write 13 to some number, and then here you're going to have 21 to some number. How convenient would it be to stop at 20? First one stops at 20, the second class picks up at 21, and has to end right before the number the third class starts at, namely 29. So the second class must stop 1 before. This is 38. So 37 goes above. This is 46, so it goes above be 45. That number is 54. What goes here should be 53. Or just add 8. 20 plus 8 is 28, plus 8 is 37, plus 8 is 53, plus 8 will be 61. And those are your classes. So let me put it back here again, please. So we have class 13 to 20, 21 to 28. Just add 8 to each endpoint. The left endpoint is 29, add 8, get 37. 36 plus 8 is 44. 45, 54, 53, 61. Those are the classes. Now, the instructions wanted us to make a frequency, relative frequency, and cumulative frequency. We're going to do a lot. We're going to do a frequency table, a relative frequency table, and a cumulative frequency table, FEQ. And we're going to do this just in one table, one shot. Next column is going to be the frequency. Once we list all the values under frequency, we will have accomplished a frequency table. Frequency. The number that goes here is the frequency, the number of times that a number landed in that class, 13 to 21. Excuse me, 13 to 20. Well, these numbers right there, they're all between 13 and 20, and the frequency, the number is 5. There are 5 of those numbers between 13 and 20. And numbers, the number of numbers between 21 and 28 is, well, you have these 3 and these 2, total of 5. So the frequency for that class is 5. 29 to 36 just has those two numbers. 37 to 4, excuse me, it just has 30. 37 is not between 29 and 36. Okay, so it should just be 1. Called a mistake. Okay, next class is 37 to 44. Well, we have all of these numbers, and I have to look to see if there's any more. But 1, 2, 3, 4, 5, 6, 7, and 8. And 45 to 53, almost everything on this row and nothing on the next row, because it starts above 53. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 again. And 54 to 61 is the last row, which is 4. Now, if we happen to add up those numbers, we get 31. So there's your frequency table. If you want also, for it being the table, to also have a relative frequency, you need a heading that says relative frequency. Okay. What's the relative frequency that somebody gets, maybe these are scores on an exam. What's the relative frequency that somebody got between a 13 and a 20? And the answer is 5 out of 31. 5 out of 31. The next one is also 5 out of 31. The next one is 1 out of 31. And then 8 out of 31. And then 8 out of 31 again. And the last one, of course, is 4 out of 31. Now, if they just asked for, if they asked for a relative frequency table, to do that, you would need to know the frequency. So you should have exactly what we have here. If you were only asked to do the frequency table, you would only do what's in red. If you were asked to do a relative frequency table, well, then you do what's in the red, and as well, you do this. Cumulative frequency. Cumulative means add up. You add up all the frequencies. This last number, if you can read it, is 4 over 31. Okay, so now we want to have a cumulative frequency table. Now, if you wanted to just do a cumulative frequency table, you wouldn't include what's in the blue. You wouldn't do the relative frequency. Cumulative. Cumulative frequency. What the number that goes here has the following, is answer the following question. Go to the class, the right endpoint, the upper class limit is 20. How many people got 20 or below? And the answer is, since it's the first class, it's just 5. Now, the next number is going to answer the following question. How many people got below 28? And the answer is 5 and 5. There's no reason to not include 13 to 20. Who got 28 or below? Not just 28 and below, but stop at 21. No, 28 and below. So we just keep adding. 5 and 5 is 10. And then we add one more, 11. That is, 11 people got 36 or below. 5 from the first class, 5 from the second class, 1 from the third class. 5, 5, and 1 are 11. Okay? We don't discriminate. We don't care what class you come from, so long as you're before us. No threat. It's 11. And then you had a frequency of 8. So 19 people had 44 or below. Then the frequency was 8 again. So you add 8. And then the frequency was 4. 10, 31. So what's going on? It should add up to 31. But 28 plus 4 is I'm supposed to add 8, so that's 27 plus the last 4, the frequency was 4, brings me to 31. That's important that you arrive at 31. And there is your cumulative frequency table. If you were just asked to do a cumulative frequency, notice when we did the cumulative frequency, we didn't take into account the relative frequencies at all. So you don't need that heading. Okay, to find the frequency table, you just need the first two columns, class and frequency. If you want the relative frequency, you need the classes, the frequency, and the relative frequency. To do the cumulative frequency, you need class, frequency, and you need a heading for cumulative frequency. Why don't we try this again? We'll use less numbers. Suppose the numbers in order was 3, 7, 11, 15, 21, 28, 29, 33, 37, 4, 5, 6, 7, 8, 9. 3, can't count anymore. 9 numbers. Okay. And some more numbers. I have 10 numbers. We have 10 numbers, 11 numbers, 12 numbers, 13 numbers. Those are 5. Those are 4. That's 9. And 4 more. Actually, that's 5 more. So we have 5, 9, 14 numbers. Okay, so you have 14 numbers. You want to make up all these tables with 3 classes. And you want 3 classes. So the first question is, what's the class width? Well, the class width is the highest number minus the lowest number divided by the number of classes. But you want to round this up. Whatever is in the brackets, round it up. So you want to round up 37 over 3. Now you can ask yourself, what's the first number that 37 goes into, that 3 goes into, that's above 37, and you'll get 39, and 39 divided by 3 is 13. Or you just do it. 3 into 37 goes 1 time, no remainder. It goes 2 times, and it has a remainder. So round it up, 13. It's a little bit more than 12, so round it up, because there was a remainder. It was exactly, let's not use decimals. The remainder was 1, so it's 12 1/3, which we're gonna round up to 13. So the class width is 13. First class starts with the smallest number, and it goes up to some number. Then the next class starts, etc. We're going to have 3 of these. But the difference is 13. The difference is the class width between the left numbers. So 1 plus 13 is 14. 14 plus 13 is 27. 27 plus 13 is 40. We now have the left endpoints. We have the lower class limits. What's before 14? 13. Now you can do that to the 27. What's right before that? 26. Or you can take that number, which happened to be 13. That's a coincidence. And add 13. And then add 13. And then add 13. And there are your classes. The 13, 26, 39, 52. Those are the upper class limits. So these are the classes. What it says right above should say classes. Now, I do have a very serious problem here. Okay. The problem was, as I said, I'm only going to have 3 classes, and I clearly have 4. However, the largest number is 38. We didn't need a 42 or 52. Sorry about that. But it's good sometimes when you make an error, because when I make an error, because I show you how you can catch it. It said we wanted 3 classes. Also, at some point when you look for the frequency and you notice it never came up, nothing above 40 ever came up, you're like, well, maybe I don't need it. Okay, here are your classes, and now you want the frequencies. Should be a Q. Well, from 1 to 13, it looks like these 5 numbers plus that. Looks like those 6 numbers. So the frequency is 6. 14 to 26, it looks like these 2 numbers. 14 to 26. 27 to 39, It looks like the last 5 numbers which are circled. Excuse me, the last 4 numbers. And that adds up to 12. So here is your frequency table. If you just asked to draw a frequency table, there it is. If you were asked to draw a relative frequency table, well, then you just take the frequencies and you divide them by the sum of the frequencies. And usually you don't reduce because you like to have the same denominators. Although in this case, you can get 3 over 6, 1 over 6, and 2 over 6. So everything is in 6. Everything you have there, that's a relative frequency. If you're asked to also put a cumulative frequency table, well, that's just cumulative, just add. The first row is 6. Now add 2, get 8. And now add 4 and get 12. And these 2 numbers should always be the same. Here, we're just doing a running count. In the end, we counted everyone. We counted people from 1 to 39. We counted everyone. It better be 12, which is the sum of the frequencies. Okay. Now, what if you were asked other questions? What if you were asked other questions? If you were asked, so you're given the table now. So you're not given anything on the top. You're just given a table. Given the classes, you're given the frequencies, you're given the relative frequencies. And somebody asked you, what are the lower class limits? Well, it's a set. It's a set of numbers. And you go to each class and you read off the lowest numbers, better known as the left-hand numbers. The numbers go from smaller to larger, from 1 to 13. You have 1, and to the right you have 2, and to the right you have 3. 1 is the smallest number. And you go to the second class, write down the smallest number. You go to the third class, write down the smallest numbers. Those are the lower class limits. Okay, define them that way. It's the smallest number from each class. It's a collection of the smallest numbers. What is the upper class limits? Well, those are just the right-hand numbers. The largest number in each class. 13, 26, 39. Can always add 13. Always add 13. Question is, where do you stop? You stop at 39 for the upper limits. You stop at 27 for the lower class limits. Okay. What if you were asked to find the class boundaries? Now, the classes are 1 to 13, 14 to 26, and 27 to 39. Those are the 3 classes. So let's get all of this out of the way. And the question is to find the class boundaries. And before you can have any prayer on getting the right answer, you need to know your vocabulary. You need to know what it means to be a class boundary. And it's the midpoint of all the gaps. Basically, here's a number line from 1 to 39. You have from 1 to 13, and you have from 14 to 26, and then you have from 27 to 39. Okay, Okay, whether you want to draw every time what I just did or not, here's the logic behind it. There are class boundaries, so I'm about to write them down. The class boundaries are a set of numbers. Here is a gap. It's the midpoint of the gap. What's in between 13 and 14? 13.5. And then you try and locate the second gap, and you find the midpoint. And you go and find the third gap. Okay, first one, 13.5. In between 26 and 27. If you're really not good at realizing that it's 26.5, add them up, divide by 2. Get 53 over 2, which is 26.5. These are the gaps, the midpoints of the gaps. Of course, once you find the first one is 13.5, you just add 8. You add 13 in this problem. You add 13 and you get 26.5. And that's it. Those are the class boundaries. Those are important numbers to know when you're making up histograms and and frequency polygons. Sometimes you need to know the class boundaries. Class boundaries are the midpoints of the gaps. So maybe you draw it on the number line and you find a number in between the gaps. Okay, what if you wanted to know, and this is an important one. Well, they're all important. What is the class midpoint? What is the class midpoint? Well, one class goes from 1 to 13. Another one goes from 14 to 26, etc. In each of these classes, what is the midpoint? What is a number right in the middle? Well, you can add 1 and 13, get 14, and then divide by 2. Oh, 14 over 2. Well, 2 times 7 gives you 14, so it's 7. And then you add 8. I mean, if you prefer, you can add those two numbers divided by 2. You add them, you get 40 divided by 2 is 20. But if you just add 13, you'll get 20. And if you add 13 again, you'll get 33. And 13 was the class width. Things happen every 13. It repeats. These people get to hang out with one another, and then it happens 13 later. If you have 1, 13, and you add 13 to both endpoints, you get 14 to 26, which is exactly this. And then if you add 13 to both endpoints, you get 27 to 39, which is exactly this. It's repeating every 13. So the class midpoints are 7, 20, and 33. When somebody asks you for midpoint of something, that means they want you to add them up and divide by 2. But you have to know what they're talking about. When it comes to class midpoints, it's the lower class limit and the upper class limit. You want to find the average of them. Again, if you want to find the class width, possibly you didn't make up the table. Somebody gives you a frequency table. They give you the classes and the frequencies of 732. So here's your table. The first column should be listed classes and the second one frequency. Somebody asks you, well, what's the class width? Well, you can take any two lower class limit numbers. Say those two. Subtract them, 27 minus 14 is 13. And that's it. The class width is 13. Or you can use upper class limits. Any two consecutive. Don't skip. Don't go and pick 13 and 39. Maybe pick 13 and 26. If you subtract them, whatever number you get, it's a class width, 13. You need to learn your definitions. Class width, you just subtract. All of you know how to subtract these two numbers. Okay, what you may not know is to do that because you don't know your definition. Class width, subtract any two consecutive left-hand numbers or right-hand numbers from their classes. Don't go to the frequency and he says, oh, this guy said subtract any two. 3 minus 2 is 1. No, no, no. Upper class limits or lower class limits. That is, go to their classes and subtract any two left numbers or consecutive left numbers or any two right consecutive numbers. And you will have the class width. Now, let's see what we want to do here. Suppose we want to make up a histogram for that data. Okay, the data being as follows. Not the original data, but the breakdown into the classes. Suppose that you are told this. 37, 44, 45 to 52, and 53 to 60. Those are the classes, and as such, it really should be labeled, and you're given the frequency. 5, 5, 1, 7, 8, 4. And you want to make up a histogram. Okay, you want to make up a histogram. The histogram uses the class, let me put it here please. It uses the class boundaries. The histogram uses the class boundaries, which was the gaps, the midpoint of the gaps. Between 20 and 21, that gap, the midpoint of that gap is 20.5. And between 28 and 29, that middle point is 28.5. And from 36 to 37, that middle point is 36.5. And 44 to 45 is 44.5. 44.5. And I guess I am putting it down here. Sorry about that. 20.5. And just keep adding 8. 28.5. 36.5. 44.5. And 52.5. Now, you also have to go back one. These numbers on the very bottom, those are the boundaries. By definition, they are the boundaries. They are the class boundaries. But there's two others that we need to talk about. For example, one class went from 13 to 20, and then from 21 to 28, and then from 29 to 36, and that was one class, and that was a class, and that was a class, and there's some others. And we're picking that class boundary and that one. And like I said, there's another class right here. And we're going to take the midpoint of the gap. And those are the numbers on the bottom. Now, they always increase by 8. 20.5 plus 8 is 28.8, plus 8 is 36, plus 8 is 44, etc. What we need to do is go 1 to the left and 1 to the right. That is, we have to go 8 to the left, which brings us at 12.5, and 8 to the right. This is for a histogram. It's just the way it is. And now you draw your frequencies. They go up to 8. Call that 8, and you have a 7, and a 5, and a 4, and a 1. The first one, the frequency was 5. Now 13 to 20 is somewhat in here. But you go a little bit bigger. You go a little bit to the left and a little bit to the right. That is, you go from 12 and a half to 20 and a half. And you go up to a height of 5. Go a height of 5. And then the next one, from just before 21 to just after 28, namely 20.5 to 28.8, we go up 5 as well. And then, if you want, you can put those numbers here, 28 and a half to 36.5. Between those two numbers, you just go up 1. And then between 36.5 and 44.5, you go up 7. And then from just below 45 to just above 52, namely 44.5 to 52.5, you go up 8. And then from just below 53 to just above 60, you go up 4. And there is your histogram. It uses the class boundaries. That's the numbers just before 37 and just above 44. Just before 45, just above 52. I'm saying that so once you label it on the bottom, you know that 8 doesn't go between 45 and 52, but just below 45, just above 52. I already numbered the bottom. Well, 44.5 is just below 45, and 52.5 is just above 52, just above 52. I'm concentrating on this one, and my frequency is 8. So I go up to a height of 8. If you look straight across, you rarely should see 8. For this one, when you look straight across, you better see 7. When you look straight across, you're supposed to see 4. And we do. Don't draw those lines, but if you happen to look across, you better see the numbers that I pointed out. That's how you do a histogram. You use the class boundaries, and then you do one before and one after. You add the class width to the rightmost class boundary. And then you add the class width, you subtract the class width from the leftmost class boundary point. You just keep watching the tape. It's only, doing other problems just have different numbers. It's not about numbers. It's about understanding the concepts. Now we're going to do a frequency polygon. And this is still for the same data. There's no real point to come up with different data. From 13 to 20, 21, 34, 47, 29, excuse me. 29, 38, 47. Why am I having such trouble with this? $37, 45, 28, 36, 44, 52. And 53 to 60, just so we have a nice clean one. And the corresponding frequencies were 5, 5, 1, 7, 8, and 4. Now here is where studying is going to help. For histograms, you use the class boundaries. For a frequency polygon, you don't. You use the class midpoints. So our goal right now is to draw a frequency polygon. And what you want to find out are the midpoints. The midpoints. So that should be in the heading. The midpoints is the average, is the midpoint in each class, which means it's the average. What's smack in the middle of 13 and 20? Well, you add them up, you get 33 divided by 2, you get 16.5. Then just add 8. Add the class width. This keeps coming up and up and up. But if you prefer, instead of adding 8 and getting 24.5 for the next one, you can add the two numbers, the lower limit and the upper limit. You get 49 divided by 2, you get 24.5. But add 8. Add 8. If you have to use pencil and paper to add 8, fine, add it. As long as you add it, you won't be wrong. Okay. Those are the class midpoints. This is how you draw a frequency polygon. You have the frequency column and the class. So like I said, it uses the midpoints. So let us draw the midpoints. $16.5, $24.5, $32.5, $40.5, $48.5, $56.5. You have to draw or place you have to, on their scale on the bottom, you have to put a number, one before the first one and one after. Just keep adding the class width. Add 8. You get 64.8. Take away 8. You get 8.5. And with respect to the frequency table, the first and last one is going to have a height of 0. I'm going to anchor the graph. I'm going to anchor the polygon. And if you think about it, nobody got a score anywhere near 64.8. The highest score was 60. And I'm not clear what happened here, but see what I can do. Okay. the frequencies. 5, 5, the highest is 8. I'm looking under frequency. 5, 5, 1, 7. You have a 7. You have a 5. You also have a 6. You also have a 2.8. You don't put every number on the scale. And using the midpoint, you go to that frequency. At 16.5, you go up 5. 1, 2, 3, 4, 5. You put your nice dot there. And at 24.5, you also go up 5. And you go 1 above 32.5. You just go up 1. Right above 40.5, you go up 7. 1, 2, 3, 4, 5, 6. Excuse me, 7 looks like right there. $48.8, you go up 8. 48.5, excuse me, you go up 8. And 56.5, the frequency is 4, so you go up 4. And for the last one, you go up 0. And basically, you connect the dots. Oops, I guess that wasn't there. Now, well, again, at 8.5, it was 0. At 64.8, nobody was in the next class. The next class would have been 61 to 68. The frequency would have been 0. And the class before the first one don't really have room, but it would have went from 5 to 12. And the frequency would have been 0. Nobody got between 5 and 12. So that's why we go to 0 on the left and we go to 0 on the right. And there is your frequency polygon. Okay, fine, do a couple. More importantly, learn the rules. You're given the classes and you're given the frequencies. You're given this right here. And you are told to draw a frequency polygon. So how you study is you say, well, if I'm given a table that just has the classes and the frequencies, and I'm asked to draw a histogram, well, I want to find the class boundaries. And you better remind yourself what that meant. If you want to draw a frequency polygon, you want to find the midpoints. The midpoint of a class, well, it's the middle number. It's the average of the upper and lower number. The average, okay? And using those midpoints, you plot the points that you got. Right above those midpoints, you go up the correct frequency. And you go 1 to the left, 1 extra 1 to the left, and 1 extra class width to the right. And you anchor it with 0 and you at both endpoints. And basically you connect the dots. That is a frequency polygon. Okay. I'm going to write this down again, and we're going to draw a cumulative. Actually, it's called an ogive. An ogive. We're going to draw an ogive. An ogive is the frequency graph. Ogive. Now, to draw, some people think they might actually call it what I've been calling it is cumulative frequency polygon. So again, it's a polygon. And this one uses the class boundaries. I don't know why the O didn't come out. It's called an ogive. Okay, now let's put down this table for the 15th time. I keep writing on it I'm definitely going to give you a clean one. Give you a clean one each time. Okay, 5, 5, 1, 7, 8, 4. This is the class and the frequency headings. And you want a cumulative frequency polygon. So we want the cumulative frequency. Cumulative frequency. Up to 20, it was just 5. But up to 28, you have 5 and 5. You have 10. And up to 36, well, you have the 10 plus you just brought on one more. Above this line is 11. But then you add on 7 more up to 44. The total of 18. Add 8 more, 26. Add 4 more, get 30. Now, again, to use the ogive, we use the class boundaries. You know, between 20 and 21, you have a gap. Class boundaries is the midpoint of that gap. Between 20 and 21 is 20.5. If you have $20 and I have $21, and we're going to share it, well, think of my $21 as 20 plus 1. Well, you have 20, and I have 20 plus 1. But forget that one for one moment. You have 20, and I have 20. We're even. But I have this extra dollar. So I have to share it with you. We each get 50. You get 20, 50. Or better yet, I ask you how much money you have. You count it. You say 20. I count my money is 20. And we're going to share it equally, so we each get 20. And then I check another pocket, and I'm like, oh, I have another dollar. Well, you get 50, and I get 50. You mean half a dollar, and I get a half a dollar. 20.5. Between 28 and 29, 28.5. Just add 8. This number plus 8 is that number. I think I'm going to get burnt again. Add 8. Add 8. And then add 8. 52.8. Now, with the polygon, okay, now, what about above 60? So we know 60 or below, the cumulative frequency is 30. 30 people on this test got 60 or below. Well, if we were going to entertain the next group, well, its frequency was 0. Nobody got between 61 and 68. So what's the cumulative frequency? It's still 30. 30 people got 68 or below. Okay? 30 people, a total of 30 people got 76 or below. Just because, you know, somebody asked you, how many of your students got below 100? Well, the answer is 30. Once you go beyond 60, the answer is still this number, 30. So we're not going to anchor this one to 0. That is, we don't need to go 1 to the right. There's no reason to do it. Okay, if you want to understand that and remember it, wonderful. You can just memorize. Only go to the left on an ogive. You go 8 to the left. You do 20.5. You take away 8. Probably use a calculator. You get 12.5. The 12.5, that's going to be 0. Nobody got below 12.5. Everyone in your class got 13 or above. So nobody got 12.5. How many got up to 20.5? 5. So, you know, you have 5, 2, 3, 4, 5, 6. Okay. 5, 10, 15, 20, 25, 30. So at 20.5, the cumulative frequency is 5. So this here is the cumulative frequency. Up to 28.5, went up to 10. And 36.5, or what happened? These are all 0.5s. I'm adding 8, so I'm saying 0.8. But of course, everyone caught that. Okay, 36.5 is 11. Just went up 1. A little bit higher. 44.5 is 18. That was a bit of a jump. And 52.5 was 26. And I did make one error. I didn't do the last boundary point. Oh, you do go 1. Excuse me. Because there are people who got above 52.5. There are 4 people. You do the next one. Sorry. And that brings you up to 60.5. And that one goes up to 30. And the ogive graph looks like this. That's the ogive graph. So let me be clear. That's the lowest boundary, and that's the upper boundary. But yet, we go class boundary, I mean to say. But yet, we go 1 to the left, and we do go 1 to the right. Sorry about that. We do go 1 to the right. Else we wouldn't have caught the last 4 people. We would not have included them. And, you know, why not include them? I don't think they would like it if you didn't. The next thing we're going to talk about is a stem and leaf graph. An interesting way to write data. Stem and leaf graph. So let me give you a stem and leaf plot. Guess that's a better word. I'm going to ask to list all the data from the table. So here is your stem and leaf graph. I figure possibly it may have these lines. But does that really change things? This is called the stem, which is to the left of that vertical line. To the left of this line is called the stem, and to the right of it is called the leaf. Hence the name stem and leaf. Let's look at the third row of numbers. 3 always goes first. You have 3 and then 3. That's one number. And then you have 3 and then 8, better known as 38. And then you have 3 and 1. And then you have 3 and 4, which is 34. And then 3 and 4 again. And then 3 and a 7. And then it's 3 and a 4, which is good old 34. Just going up, you have 2 and then a 3, 23. And you have 2, the stem always goes there. It like distributes. You now have 2 and 7. I'll only go into another line because I ran out of space. And then you have 2, 2. And then you have 2 and 1, which is 21. And you could have gone from the top. It doesn't matter how you list their 20 different numbers or however many there are. 1, 2, which is 12. 1, 4, 1, 7. You want to put it in increasing order and decreasing order. Doesn't matter. Now the reason I didn't do the top one first is I didn't want to start with a problem right in from the get-go. 0 is 3, which I'm writing in the top right. We're going to call that 3. And 0, 7, we're going to call that 7. And 0, 9 is 9. 0, 0 will be 0. So 0, 3 is 3, and 0, 5 is 5, and 0, 5 is 5. In fact, you just get those 5 numbers. You get 3, 5, 5, 7, and 8. Okay, so now, if you're able to do this, then you know how to read a stem and leaf graph. It's very simple. The stem comes before this vertical line. And you put that stem in front of each and every number afterwards. The leaf doesn't have to be 1 digit. I suspect nor does the stem. For example, you can have, say, these 3 stems. And you can have 78, 22, 11. Let's make that 41, 73, 19, 88. These numbers are completely random. Well, this is 178, 178, 178, 1 and then 2, 2. Oh, 122. I recognize that. A 1 and then a 4, 1. Oh, 141. Why didn't you say so? 2 and then 73. 2 and then 19. 2 and no comma and then 88. 288. 333. 3 and then 03. 3 and then 79. That is how you read numbers off of our stem and leaf graph. Okay, let's reverse the game. Up to now, I've given you stem and leaf graphs, and I'm asking you to list the data. Well, now I'm going to give you the data. 107, 193, 208, 217, 109, 293, 301, 308, 396, 222. And I ask you to complete this stem and leaf graph. And I'll just give you 1, 2, and 3. The first thing I would notice is that all of these digits, all of these numbers are 3 digits. So this must be the first digit. So whatever I put to the right must be 2-digit numbers. Like 1 and then 0, 7. So I go to the 1 row, and then I put 0, 7. 193. I go to the 1 row, and I put 93. And then 2, 0, 8. I go to row number 2, the row that has a 2 in it, and then I put 08 next to it. Row that starts with a 2, and then 1, 7 in the leaf part. The stem should be 1, which is right there, and then I put 09 as a leaf. The stem is 2, the leaf is 93. So I go to the stem that's 2, and in the leaf I write 93. 3 is the stem, and then 01 is the leaf. 3 is the stem, 08 is the leaf. 3 is the stem, 96 is the leaf. 2 is the stem, 22 is the leaf. I went to the stem that was 2. And this is how you would write a stem and leaf graph for those numbers. In other words, I didn't even have to start you off with the 1, 2, and the 3. It's numbers as two-digit numbers. Like, if you had to order numbers between 200 and 299, like 207, 203, 209, well, I don't mean them all to be with a 0, 20 stuff. You can have 247, 296, 233, 219. If I said put these numbers in order, it would have been nicer if I somehow just gave you those numbers. It would be more pleasant to look at. They're two-digit numbers. Once you tell me that here's a list of numbers, put them in order, I really don't like that problem. But I'd rather have two-digit numbers than three-digit numbers. And with respect to a stem and leaf graph, for row 2, this is exactly what would be by row 2. 11, 07, 03, 09, 47, 96, 33, 19. So I can somewhat easily tell you, well, maybe not easily, but with a greater probability of doing it correctly. This is 203, 207, 209 here, 211, 230, 219 after 211, 233, 247, 296. It's a lot easier for me to arrange those numbers, and I said them correctly. I didn't say 379, I said 203, 207. So I have the right list. Now, if you ask me to order it here, it'd be harder because all these 2's are in the way for the 200. The stem and leaf graphs are not so bad. They're not a bad way of listing numbers or grouping data. This finishes the first section of the video.